Okay, so we are looking at basically what causes winds and what are fronts. And the basic information on that is it's just a difference in density of air. Cold air is more dense than warm air. Cold air masses have high air pressure. And it's not that they're stacked high, they're actually low to the ground, but they're all this air is descending in. If it's at the pole, it's cold and it gets packed closer and closer together. It's kind of like, except water, which expands, everything else as it gets colder, it gets closer and closer together. Um, and that's a big deal. And there's a difference in density. So cold water, your bathtub even will sink to the bottom and the warmer water will be on top. So if you ever take a bath and your bath water is getting cold and you go run more hot water in it and you put it over the overflow, that you're actually siphoning off all the warm water. Before you add the hot water, you should actually drain about an inch or so from your tub. That takes the coldest water out of the bottom. Put your plug back in and then add your warm water. You will actually have a warmer bath because even in a bathtub, the colder water will settle at the bottom and the warmer water will rise to the top because it's less dense. So, really, the cause of wind is a change in pressure, and everything flows from high pressure down to low pressure. So, air moves from high to low, just like a waterfall also moves from high up to lower down here. You're never going to see water flowing uphill unless it's being pumped or carried. But gravity wins, it flows from high to low. So, as we look at this, we talked about this a little bit in the last set of notes that high pressure cells, due to the Coriolis effect, will rotate in a, here we go, look at this. We can see it. Here's my high pressure, it's rotating clockwise. And my low pressure is rotating in, but it's going counterclockwise. And remember, we talked about the fact that as this cold air leaves my high pressure cell, it wants to flow over to the low pressure cell, where all that cold air is replacing that hot air. And as it comes in, it might warm up, right? And then it starts to rise and it flows and it rises as it flows in, it heats up and it rises. So then you have to have more cold air come in to replace it. So it's never a straight line. And if you put your back to it, I mean, if you were standing right here and I put my back to the wind, I could look and my high pressure is roughly off to my right and my low pressure is roughly off to my left because as this is swirling around. Now, it would be a little different if you were up here, right? So it's interesting that you know that high pressure to low pressure is a big deal. High pressure cells are clear and cold. This is a test question. High pressure cells are clear and cold. Low pressure cells are warm and wet. Really good test questions. Big star. Need to know it. So, big star point. This you need to know. When I was little, and my dad was a math teacher, if somebody got a perfect on their math test, he would let me draw a star, and I would turn him into a sheriff. And you can tell, oops, my pencil's a little off. You can tell I am not the world's greatest artist, which is ironic as I have an art minor. And I have an art minor because I have a massive amount of photography in my college and high school and technical school. And I also had a lot of art history, so I have an art minor. Best and worst class I ever took was drawing class in college. Best because it really forced me to go outside my comfort zone and I found out I could do it. And worst because it was really hard, which is a good reason to do it sometimes, to push yourself. So remember that Coriolis effect. Moving objects appear to be deflected to the right in the northern hemisphere due to the Earth's rotation. So, deflected due to the right in the northern hemisphere. Good test question. So if I'm looking down, it goes to the right. High air pressure masses rotate clockwise due to the Coriolis effect in the northern hemisphere. and low pressure cells rotate counterclockwise. This clockwise rotation for high pressure and counterclockwise for low pressure, also very good test questions. So if we were doing this in class, and I'll ask this here in Edpuzzle, if air always moves from high pressure and you know in which direction high pressure cells rotate in the northern hemisphere, if this is the southern hemisphere, is this the southern or the northern hemisphere? Because if we go back up here and we know that high pressure cells rotate clockwise, is this rotating clockwise or is this going counterclockwise? Answer that question. Well, that's going counterclockwise. So this can't be the northern hemisphere. This must now be the southern hemisphere. Okay, that brings us in to our global fronts. And this gets into those Hadley cells and where we have, remember, everything doesn't go just from the equator and flow down here. It actually goes and hits there. This flows down, this flows up, they meet, and we have rising air. So we have those three cells, right?